You know, generative AI is incredibly powerful, but right out of the box, it's kind of clueless. It doesn't know about your company's latest report, your internal docs, or what's happening in real time. So the big question is, how do you give your AI applications access to all that private, up-to-date info securely and efficiently using AWS? All right, let's get into it.
And this really is the fundamental question, isn't it? For your AI to be truly useful, it has to understand your unique data. We're talking internal wikis, customer support logs, financial reports. We need a way to bridge that gap between a generic model and your specific world of knowledge.
The key to cracking this whole thing open is to teach the AI a new language, a kind of universal language of meaning. And that language is built on this really cool concept called vector embeddings.
So what on earth is a vector embedding? Well, put simply, it's a way to turn any piece of data, a word, a whole document, even an image, into a long string of numbers. Think of it like coordinates on a super complex, multidimensional map. But here's the magic. Those coordinates aren't random. They actually capture the meaning of the data. So words with similar meanings like king and queen end up being neighbors on this map.
In this diagram, it lays it out perfectly. See, you start with your raw data, maybe a bunch of documents sitting in an S3 bucket. Then, an embedding model, something like Amazon Titan, reads through that data and turns every piece of it into a vector, that set of map coordinates we just talked about. Suddenly, all your messy, unstructured text is in a clean, mathematical format that an AI can actually understand and work with.
Okay, so now that our AI can grasp the meaning of our data, we can finally tackle one of its biggest weaknesses. We can give it its own private, specialized library to look things up in.
And here's the thing you've got to remember. Standard large language models, or LLMs, have some serious blind spots. They can hallucinate, which is a nice way of saying they just make stuff up. Their knowledge is often months, if not years, out of date, and most importantly, they have zero access to your organization's private, proprietary information.
So how do we fix this? The solution is a really powerful technique with a great name, Retrieval-Augmented Generation, or as everyone calls it, RAG. And it's not just theoretical. As Julian Schamann from Hugging Face points out, pros are already using it to ground AI in these huge specific knowledge bases, like a massive library of case law for lawyers.
I love this analogy. Think of RAG as giving the AI an open book exam. Instead of just trying to remember everything from its initial training, the model first gets to retrieve the relevant facts from your private library, that specialized vector database. Then it uses that fresh, accurate information to generate its answer. The result? It's way more accurate, timely, and totally context-aware.
Let's just trace the workflow here for a second. First, your content gets crunched by an embedding model. Step 2, those vectors get stored in your vector database. That's our library. Then, when a user asks a question, the application zips over to that database, finds the most relevant documents, and finally, it hands that context over to the LLM so it can generate a smart, fact-based response.
Awesome. So you're sold on RAG, you're ready to build on AWS. Now you hit your first big fork in the road. When it comes to your vector database, AWS gives you two main paths to go down. And this is the classic developer trade-off, right? On one hand, you've got the individual services path. This is for when you want maximum control, total customization, and you're comfortable managing the components yourself. On the other hand, you have the managed service path. This is all about simplicity and speed, letting AWS handle the nitty-gritty complexity for you. So let's meet the contenders on each of these paths. This will help you figure out which approach is the right fit for you and your project.
First up, Path 1. This is for the teams that want to roll up their sleeves and get their hands dirty, the ones who want fine-grained control over their vector database infrastructure.
On this path, you've got 3 really solid choices. First, there's Amazon Kendra. Think of Kendra as the RAG specialist. It's built for enterprise search, and it even automates a ton of the data prep for you. It's probably the fastest way to get a powerful search experience running. Next, you have OpenSearch Service. This is your go-to for massive scale and real-time analytics. If you're building something that needs to search billions of vectors super fast, OpenSearch is an absolute powerhouse. And finally, for teams who are already living in the world of relational databases, there's RDS for PostgreSQL with the pgvector extension. This is such a pragmatic choice, right? It lets you add vector search right on top of your existing database, which can make your architecture a whole lot simpler.
Now for path number 2. What if you don't want to get your hands dirty? What if you want to abstract away the complexity of not just the database, but the entire RAG pipeline? Well, that's exactly what Amazon Bedrock Knowledge Bases is for. It's designed to handle all of it for you.
Now, what's really cool here is that Bedrock Knowledge Bases isn't a single database. It's more like a smart management layer that orchestrates the whole RAG pipeline, and it lets you plug in the best engine for your specific job. For example, you'd pick Aurora PostgreSQL if your vector data needs to live right next to your traditional business data. You go with OpenSearch Serverless if you want all the power of OpenSearch but without having to manage any servers. For apps that need absolutely top-tier performance on vector search alone, the purpose-built engine from Pinecone is a fantastic option. And if your app needs split-second, real-time responses, think live recommendations, then the in-memory speed of Redis Enterprise Cloud is going to be your best friend.
Okay, that's a lot of options, I know. So, how in the world do you actually make the right choice for your project?
Well, you need to think through a few key things. How much data are you going to have, and how fast will it grow? That's scalability. How fast do your answers need to be? That's query performance. You also have to consider how you'll get data in, what the cost model looks like, and of course the big ones, security and compliance.
In the end, it really comes back to that core trade-off we talked about earlier. There is no single best answer that fits everyone. It's all about finding the right balance between your team's skills, your app's performance needs, and where you want to be on that spectrum of control versus simplicity.
So, what's your game plan from here? You can really break it down into 3 clear steps. First, just take stock and evaluate what you really need. Second, don't just sit around theorizing, spin up a quick proof of concept. Try one out. And third, once you've found a winner, start planning carefully for how you'll take it to production and scale it up for the future.
So remember, a powerful AI is great for sure, but an AI that is grounded in your specific proprietary knowledge, well, that's a true game changer. At the end of the day, your AI is only as smart as the library you give it. The only question left is, what are you going to teach it?